Okay, so I did some studies, the source of AC from the Marduk for 17 Hertz, and I came up with ACE notes, TEM spectrum, UFO sightings, Kepler's planets in outer space based on links from the Marduk for 17 Hertz. This is part 33. Okay, so John Keel notes that in most UFO sightings, what he does is he's trying to explain that the UFO sightings are based on super spectrum that's in the atmosphere, and he talks about, John Mitchell concludes that the propensity of UFOs to fall may be due to geomagnetic origin. He's saying the geomagnetics are generated by the earthquake lights, so our super spectrum during times of abnormal EM activity in these window zones, the gateway between our territory and their borderland, may be open during these times. So he's saying that it's not UFOs that you're seeing, but stuff from the earth. But radio waves are also emitted by other things such as stars and gases in space. So I've been looking at, spectrum, trying to figure out what it is. So this is my thoughts. Quasars with radio waves, future video. It's a future video about it, are stars that have signals coming from them, like the WOW theory is a signal picked up from outer space, one that is 30 years old and has been completely deciphered yet. And then over here I've got pictures and stuff of stuff that I found out. Gamma ray, X-ray, visible, something, and then radio. Radio waves, visible light, X-rays, and all the other parts of the electromagnetic spectrum are fundamentally the same thing, electromagnetic radiation. So EM spectrum came up, and that's what they read to find out if it's a planet or not. So they look at the microwaves in space are used by astronomers to learn about the structure of nearby galaxies in our own Milky Way. I found that at Image GSFC NASA government. In space, IR light maps the dust between the stars, and that's how they read whether or not there's planets nearby. Stars and other hot objects in space emit UV radiation, so they look for that. Hot gases in the universe also emit X-rays. They look for that when they're looking for planets. Gamma rays, short wavelength, high frequency, high energy, big particle accelerators that scientists use to help them understand what matter is made of can sometimes generate gamma rays. But the biggest gamma ray generator of all is the universe. It makes gamma radiation in all kinds of ways. Kepler's supernova remnant, views from Chandra, Hubble, and Spitzer. X-ray observatory, visible, infrared, and this shows you what it looks like up close. And then there's the details about it. Nebula type, 13,000 light years away, found in 2004. These images represent views of Kepler's supernova remnant taken in X-rays, visible light, and infrared radiation. Each top panel shows the entire remnant. Each color in this image represents different regions of the electromagnetic spectrum. From X-rays to infrared light, the X-ray and infrared data cannot be seen with the human eye. Astronomers have color-coded these data so they can be seen in these images. The bottom panels are close-up views of the remnant. In the bottom center image, Hubble sees fine details in the brightest, densest areas of gas. The region seen in these images is outlined in the top center panel. The images indicate that the bubble of gas that makes up this supernova remnant appears different in various types of light. So before they thought it was just a supernova, but in supernovas that's where they find planets and moons and stars. And in this case, back in 2004, they took a picture of it, and now here we are in 2012 actually going, and with the new James Webb telescope that they've got, it's picking up a lot more of the Kepler planets and that they're habitable. So here you go from one little spot to like 22,000 planets that are habitable. So it's kind of interesting how fast our technology is evolving, because this is from October 2004 and here we are in 2012, January the 5th, 2012, where we're talking more and more about Kepler from the SETI Institute. So that's kind of exciting to see how fast our technology has gone.